Good afternoon, everybody. Are you with us?
It's Friday.
It is. How's everyone feeling about that?
Well, it's Friday.
Yeah, it's another day. It's Groundhog Day.
Another day and another move to remote and quarantine. My wife, who's a teacher, just got quarantined.
Ah. Well, hopefully you're not in Michigan, are you?
Yeah, we're in northern Michigan. We're out in the middle of nowhere, and you wouldn't think it would be this big a deal, that many, but it just, everybody in the area just, when spring break hit,
they all went and got whatever they needed.
It was like everybody left, and now we're reaping the rewards.
Reaping the rewards and paying the price.
Yeah, so we didn't go anywhere just because of that, but you know, can't keep other people.
Yeah.
You know, so it you know, whatever, it is what it is, but hopefully there's, you know, those people that get it. And I went to the grocery store today, and I have my robotics team. One of my girls on the team got quarantined, and I went after school to grab some groceries, and as I'm walking out of the store, there's the girl who got quarantined and her mom, neither one of them wearing masks.
Here we go.
I'm like, I thought you were quarantined is why you couldn't come to practice.
Jeez. Yeah, we don't learn too well sometimes, do we?
I'm like, okay, all right. Maybe you don't need to come to practice for a couple weeks.
Is that my dog ate my homework type of an excuse?
I don't know, but COVID has been becoming a pretty popular excuse.
We had students that were supposedly in quarantine, but they even showed up to school.
No.
Wow.
Yeah.
Wow.
I know. I had a student this morning came up to me and says, my sister's sick. I'm like, really? How's she doing? Yeah, she's got COVID. I'm like, why are you in school? Says, because my parents said I had to go to school. So
You almost blurted out, I'm here to spread it.
I'm like, I didn't follow it up. I said, hey, you know what? We're going to change where you sit.
Well, I got to hand it to all of you. This has been a really rough year. I hope it's way better next year.
I was teaching one day and I hear a couple of guys at the back of the classroom talking. Hey, Charlie, how long did it take to get your COVID test back? Oh, 5 days. Ah, man, they said mine wouldn't be back till Sunday. I was like, what? Why are you getting tested? Because the whole family had it. And yeah, same thing. I've had 5 quarantines so far this year.
Yeah, wow. This is actually my wife's 3rd time being quarantined. And I unfortunately have not been quarantined. I mean, even though which I don't quite understand, but my wife has been quarantined 3 times because she's had direct with parents that have come in or something or another, or with students, because she's an elementary teacher. And but she's never shown any symptoms. So apparently that must be why I never got quarantined. I'm feeling left out, to be honest.
Well, let's start our Robo Friday and we'll get the weekend started, because the sun's probably out and I don't know what everyone's doing, but probably a little bit of outdoor something, garage organization or so today's pretty informal and we'll definitely wrap within an hour. This is really your time. I have an agenda that I'll share with you and let you ratify the agenda and throw out any questions, comments we've got. But basically, I thought we'd do a little bit of housekeeping. Having watched you through the week, I see that everybody's learning quite a bit and progressing and becoming independent with this. And I thought I would loop back and fill in a few voids that we didn't explain, just to help your knowledge base so you're ahead of the game with your students. And then we'd review the 2 circuits that you may have built since Wednesday. And I'd like to show you some additional projects with the Cyberbot and look at the cybersecurity tutorials and the What's a Microcontroller series that's coming. And then we'll do our award ceremony. There's about 300 pages more of tutorials being released this summer that Cyber and Parallax are working on together. And we've had one of our engineers, Andy, who you met on Wednesday, working on that. So I'll just give you a quick overview of that later near the end. So any questions, comments, sort of not related to light following and infrared circuits at this stage? Or concerns or things you want to know but you're afraid to ask?
I have a question. In those expansion kits, there are like orange wheels and there are tires and things of that nature. Are they specifically for the Bobot as well?
Is this Felicia? I didn't catch who was asking. Okay, I think what you have is actually, you have hardware from Exploring Robots. Thanks, Matt. I think what you have is a package from Exploring Robots, so I'd have to look at it.
Okay.
Yeah, but I'll show you the kind of the preferred purchasing path and the cheapest way, how to make your money go furthest, et cetera. And then how to get some free money too. Because that's out there through cyber.org. They put robots out through their grants every quarter, and it's Parallax hardware. So before I get going, Matt, do you have a minute to speak about cyber?
Sure.
Okay, maybe you can also cover the, just talk about what's available for them, microbit related, and I'll stop sharing if you want to take it.
Yeah. Let's see. Let me pull up a couple of things.
Didn't give you much warning, but I can chat for a minute if you want me to instead.
Yeah, chat for like 2 seconds so I can just pull up a few things here.
2 seconds. Okay, then I'll just say that I sent out about 6 source code files, some hex files to you, and we'll be talking about those when Matt is done.
Since you mentioned that, the source code for the controller comes back with an error message. Is that set up for working with the 2.0?
Yeah, I used it, and it might be that you don't have the modules on the microbit that you need.
I don't. Okay, that's it.
And you all should be saving this source code in your special place and giving it appropriate names, because you're going to come across a lot of cool examples. So start developing your notepad or however you organize yourself to index your own code if you don't use GitHub. And if you do use GitHub, you need to teach me GitHub.
Okay.
So while Matt preps, cyber.org is the organization we've been working with for about 10 years at Parallax. And they're funded by Department of Homeland Security to produce a cyber-ready workforce in the United States. And so much of their material it's all free, actually.
All right. I believe, am I sharing the appropriate screen here?
Yes, sir.
All right, fantastic. So this is our site for cyber.org. Cyber.org, I don't know if Ken just said this or not, but cyber.org is a grant-funded organization funded by the Department of Homeland Security to help provide free curricula to teachers in the United States that is going to be cybersecurity related in order to help build a future workforce that the country is currently very much lacking. So what I've got here, this is our website for cyber.org. Very simple name. It's the same name as the company, cyber.org. So what we have is we have all of our curricula available right here. If you're interested and you are in fact a teacher in the United States, all you'll need to do is go to sign up. You go ahead and fill out your information and you will be able to have free access to all of the curricula that we provide. In that curriculum, we have things such as our cyber literacy content, which was curriculum written with Parallax, that's surrounded by the Bobot, ShieldBot, and of course the Cyberbot that you all have been working with all week. We also have our cybersecurity content, which is one of our newest additions. This is what Ken was speaking about earlier. That was also in collaboration with Parallax. This also will help students become certified using the CompTIA Security Plus. I believe I mentioned this with a few earlier in the week, but we also have our robotics in the classroom course. This is going to end up being the competitions that we host locally in Louisiana, but we have the challenges and the guidelines for those competitions available if teachers want to be able to run those competitions in their classroom, or if they want to end up trying to set up a competition locally. And then the last two things that I have to show is our events. If y'all are interested in seeing any of the other workshops that cyber.org might be hosting, or any of the events that we have coming up, please be sure to take a look at cyber.org's events. One of those events is actually going to be happening in 2 weeks. It is our high school CTF, which if anybody is interested or has been curious about CTF or what a CTF is, it's a capture the flag competition that is typically going to be centered around cybersecurity and hacking modules. We have a demo currently set up at cyber.ctfd.io. If anyone is interested in taking a look, it's free to sign up. We will not send you any emails or anything along those lines. So definitely, if anyone's interested, I do strongly suggest it. And I think I just burned through everything very quickly. If anybody has any questions, please let me know.
Thanks a lot, Matt. That was great. And I'd like to add one thing to what you just shared, which is your technology grant program. I took over sharing. Hopefully it came back. And I'm going to paste a link in the chat right now. And this is a quarterly program where cyber.org gives out hardware to educators, and you can specify what you want. There's an application, and it's very productive. And the funds go straight to hardware that we will send out, that they will award to classes based on need and socioeconomic type variables. So it's been quite effective. So that link is there, and yeah, get a look at that. Okay, let's talk briefly about a couple of the codes I sent out to you. And this was the first one, which I'm sharing right now, and it's a long list of notes. And I know a lot of you saw this and you knew what to do with it right away, how to simplify it, but it's absolutely common that students, once they get going with robots, and they won't have much regard to timing or the number of commands or the memory, but you're programming in Python on a memory limited device. So embedded controllers that run this MicroPython code base are running a little operating system that takes up memory. And so you have to pay attention to these things. Eventually we'll get an out of memory error. But I took this code and then I just put it into a loop like this, a for next loop, or in Python, a for x in range loop, where I index through, and then I played out the notes and the duration of notes that accompanied the index number. And so this shortened things up quite a bit, and you can compare the memory usage of both of those. I think it's pretty common that we see this kind of thing, and this is really where you can turn them into better coders. Here was the second thing I sent out. This was the maneuver with motion, and this is the hex file. So this reduces down the maneuvering to something very small, putting the functions in their own module called motion. So it really abstracts them. And if you want to look at the motion import, you could do that by going to load save. Since it's in the hex file, you can come in here and then actually download it from the microbit to your desktop and then open it separately. Next thing, so another student project. We had this competition a while ago where let me see if I could find it. Here we are. I put together this contest, and the idea was use the internal compass on the microbit as feedback to the robot to go in a square. And so what I envisioned with that was that you would be monitoring the compass until you are in the right heading, and then you would drive for a while, and then you would turn until the compass value reads what you wanted it to read. And I'd never tried this. I just threw this out as a competition. And I got back one submittal, which was interesting. And of course, the student who submitted it won a gripper, which is really cool for him. And it wasn't until today till I could really look at the code. And I want to know if any of you have looked at it and how you would improve this code. First off, has anyone looked at it? Maybe a thumbs up or. And I just sent it at noon Pacific, so you probably haven't really seen it. Okay. Looks like Lynn looked at it already. So Lynn, did you have any ideas on how to improve it or how it works? Okay, Lynn's being shy if he unmutes. All right, so this code pretty much calibrates the compass. So if you run it, you have to manage your way through this compass calibrate routine in which you position the robot in all possible angles until the LEDs are filled up. Once you've done that, it comes down here to while true. So we'll skip over the functions. Okay, they're passed until they're used. And you see that we get the X and the Y values from the compass. The compass also puts out degrees, but it looks like this student knows more about turning this into angles than I do. So that's what happened. And so he calculated some angles. And this is where it gets interesting. So he put the robot down next to his phone. Let's look at the video, actually. I have a video from him, so I'll just bring that up. This may not play well through Zoom. So I said, use a phone to prove that you're going north to start. It is interesting as a 9-volt battery, which is a little, not really a good idea, but okay. Now let's go look at the code again. So he put it down at a known angle between 45 and 135 degrees, which he figured out was north. And then he showed north, and then he just went straight forward. And when he does this forward, he also turns right afterwards, which is right here. So he goes forward, then right. So he did what's called a dead reckon turn right. He figured out that about 500 milliseconds at this speed will turn him about 90 degrees to the right. And then he checks to see where he is. And if he's within 90 degrees of where he should be, then he continues on driving and he displays that value on the microbit. So it actually works, but what would be a better way to do this? Come on, someone knows. Okay, you're all quiet. All right, I think the better way would be the following. Drive forward until you want to check the compass. Stop, and then rotate until you are within the angle you want to be exactly. So you could rotate until you're within a few degrees of where you want to go, and then stop rotating, and then go forward. So you could use the compass as a real-time feedback when you're turning, rather than this combination of I'm within 90 degrees. If I'm there, just go right and show the value. So there's always a better way. Next thing I want to speak about, and this is a little bit confusing, but maybe now at this stage it'll be more clear. And it's the hardware design of the Cyberbot and how it relates to the cyberbot.py file. Pardon me while I jump on down to a slide. Okay, so when you are programming the Cyberbot, you're using the bot 18, bot 19, bot anything to do a lot of different commands. And all of those commands go through the chip that's underneath the board. And we put that on there because it gives a lot of capability to the microbit that it does not otherwise have. And I'll tell you about some of those things. All right, so when you say bot 18, 19, or bot anything, you're restricted to using the library that we've actually published. And that library is right here. Okay, it's published on our Learn site. So these are all of the commands you could use. Just pasted that link in for you. Let me zoom in, just give a quick look at what they are. So these are all the main robot commands. You can do analog IO, read IO states as high or low. You can generate and measure pulses that are timed. You can make sound. Okay. You can position a servo at an angle. You can also control a servo with speed. And then there's another servo you can control called the Feedback 360 servo. This servo lets you drive a distance. And it matches them, and it has an encoder feedback. So right now, when you pulse your servos, your robot will never go perfectly straight because the motors have no feedback to the control system that allows it to check on itself. When you drive down the road, you're looking at a straight road even. That road might have a 2-degree camber on it, so water flows off. And your feedback is your eyeballs and your hands on the steering wheel. So the Cyberbot is just driving without any feedback. However, there is a servo motor that has feedback that tells us how many times the wheel has rotated. So there's a command for that. And this allows you to go to a distance within 1/64th turns. So if you're doing something like maze solving, this could be very important because you might want to build a virtual maze inside of the Cyberbot's memory. And there are commands for addressing groups of IO pins, like for driving 7-segment displays or talking to the ping module. Felicia has an example of that for the line follower, etc., or the TV remote control. And this is the kind of thing, if you're talking to TV remote, this really needs this level of abstraction because you want to press a button and just be able to read it. You don't want to have to sort through all the pulses. That's more of an engineering challenge that's really above our students. So if you want to use the microbit without the propeller, you have 2 ways of making that happen. I'm just going to switch over to my document camera to show you that. So when you go to the all the documentation on the microbit Read the Docs Python site, you'll find a ton of examples that use the microbit, and they're unaware of the Cyberbot, of course. So you have 2 ways of getting to the microbit IOs. You can get there through these round pads by putting an alligator clip on there. If you have little alligator clips, or a banana plug might fit in there. There are a lot of fun microbit accessories that you can connect to this robot. And then you would not use the cyberbot.py to talk to those modules. But there's something new. And you have from us the latest microbit, that's the V2O, and the latest cyber.org board. If you look on the bottom here, I'll zoom in for you. You see 4 pins that say microbit IO. So you can get to 4 more pins this way. So you can get to, I think, a total of 7 of the microbit IO pins and do all kinds of stuff that do not require the Cyberbot library. Any questions on that? Give me a thumbs up if that makes sense. Okay. Monday, this would have made no sense at all, right? Okay, good. Yeah.
Those particular pins, are those solder connections? Or could you do those with banana plugs or that kind of sort of thing as well?
Yeah, these are soldered connections, and we probably could put a little male-female header in there on a future manufacturing run.
Yeah,
So,
that would be really nice.
yeah, would you like that? And I think that's a revision we can sneak in without anybody knowing. Usually when you make changes, like this is Cyberbot Rev B board that you have. we change the revision number, but we don't want to obsolete anybody's hardware. We're very sensitive to that. So I could sneak that in on the future run and keep the same revision number so that people have that. Otherwise, yeah, you can solder.
Okay, thank you.
I know it's really hard to
Ken?
solder on it. Yeah.
Are those addressing the microbit directly, or are they addressing the propeller?
Yeah, those are directly to the microbit, Carol.
Okay,
Yeah. I might have to update your hardware as well then.
yeah,
Oh, so this is fun. We have Carol here. She has something for show and tell as well. Okay, so the next thing I want to talk about was the Mew Editor, for those who are not familiar with it. There is an editor you can download, and here is the link. I'm just going to copy it in. It's called Code with Mew. Are you already familiar with this? Anybody? Okay, it might be new. So if you are running a class with Windows machines and with Macs, I really prefer this tool. And it is more of a complete professional editor. I've got it up here. And it has buttons and things that just feel a little more natural than the browser-based version. So you can download this, and the way you add the cyberbot.py file is you just click on the Files button, and you can go to this little window on the bottom, and actually I'll remove it first. You just drag it over. So well, that didn't quite work. Hey, Matt, I forgot, how do you add here? Do you click on?
So you had to find the Mew folder, and
Oh,
you
the
had
code.
to add them
Okay.
directly in the File Explorer. However, if I remember correctly, if you do have the cyberbot.py extension already on your Cyberbot, you should be able to add it through Mew that way. So you could use the browser-based editor to be able to put that library onto your Cyberbot, and then use your Cyberbot to make that library easily accessible through Mew.
I had forgotten how to actually add the file, even though I made the video that's on our Learn website. But anyway, I think it's like, is it load or? Yeah, anyway, it's files. That's it maybe, but how do you add? Okay, well, that didn't quite work. Anyway, there's a video on our website, and you can scrounge that up and find it. So one other neat thing about Mew, I can find it again. It seems to have closed on me.
use File Explorer to,
Oh, you drag
it
and drop
into-
it to the Code with Mew folder.
yeah, into the Mew
Okay.
folder. Mew code folder is what it's called.
And then it appears there.
And it automatically appears on your Mew when you bring it up and hit Files.
Yeah, okay. So you just put the libraries into the Mew code folder, and then they appear when you go to this Files button, and then you can just drag them onto the device.
Mhm.
One other great thing about this tool is that it has a plotter built into it. So it can intercept the print commands and then display them in a plotter. So give that a quick look. I have a microbit connected at the moment, so I flashed, but I didn't see much. Okay, here we go. So this is the 3 axes of the accelerometer as I move this around. And the data flood is detected. So when that happens, you just kind of need to increase the sleep command. And to reload and then restart the plotter, you need to close it, I believe, and then flash, and then you can open it again. So if I just pull the module up and down, it looks like the orange would be the Z-axis. And then when I go left to right, the X is blue, and then the other way would be the green one.
So
So
does
it's
the Python.microbit platform that we're using, does it have a plotter built into it, or just the?
No, it has just the REPL, which is the serial terminal where you can display the text. So if I close the plotter, what the Python editor has, that this also has, is REPL. And REPL displays data just scrolling as text. It's really called a serial terminal. So I'll leave that up to you to go and investigate. But the point is, one thing I wanted to show you with that accelerometer is there are devices on the microbit that are really good for robotics. The radio is one, the accelerometer is another, the speaker is one, the LEDs for feedback, and I'm not sure if I missed anything. But one application I've not seen done that I will ask through a contest soon is to use the accelerometer as a bump detector. So we'd like to see that accomplished somewhere. Any questions about Mew? Okay, if no questions, let's review quickly the applications that you may have built and see if you had any questions about how they work. And if anyone wants to share any results of them, that's good time to do that would be now. So we had the light following. And who succeeded with light following? Thumbs up or thumbs down. Okay, and tell me about some of the observations. Thumbs down if you failed, okay. All right, so what were the observations of the light following activity that people made? Will, you spent a lot of time on it. So what did you do with this activity? Or Lynn, I'm sorry. Okay. All right. So one of us, and I have some pictures of the application, spent a lot of time trying to filter out different colors using a light source with some transparent red, blue, green, and then recorded all the different light levels that were observed. And I could bring that up. Okay, so this was Lynn's setup. So built the robot, and then he's a physicist, so he really likes light. And he put these over the light source. And then he measured different light levels, the voltage at the robot. And some of his results look like this. This would be with the blue. 3 volts. And then with the ambient light, 0.15 volts. So he could actually use that as a cheap color sensor. So good job there. All right, is it an analog or a digital circuit? Who knows? You can put it in chat if you want. Yes, it's an analog circuit. Okay. And more light, more voltage, or the other way around? Anybody? Okay, we're very quiet now.
Okay, I'll say something. It was the brighter it was, the lower the number, I believe, the lower the voltage. A 50-50 chance, I forgot now, but
I thought it was more like higher voltage, and then it stopped if the voltage got less than a value of 1. That's what I'm remembering.
Yeah, I think you're right. More light, higher voltage.
okay.
And there's good documentation here about Ohm's law and how you can take measurements and prove out Ohm's law. So encourage that. And it was pointed out too that it doesn't work terribly well with a flashlight. So if I switch over to demo, for those who didn't get to see this or build this, I'll show you how it works right now, because it's really fun. And there's a lot you can do with this. So I've got an LED flashlight that I bought off of Amazon and Cyberbot ready to go. So I can control it quite nicely. Although this wavelength of light is really not what these are tuned to. So you might find that you're putting the flashlight or your phone really close to it to get response. But what's interesting is the power of natural light, which is what these are tuned to. So over on the other side of my office, where this robot is going, is natural light. And it will find its way there very, very nicely. So if you just leave your door open, any indirect light will be enough for this robot to get its way out. It's a very, very effective system. So you could put all kinds of things in the way and have them use other sensors to get around objects while getting towards the light.
Yeah, I kind of found that out with using the light on my phone, because that's the LED light, of course. And so it didn't want to really follow it too well. Didn't change much.
And did you take it outside or put it more like where there's indirect sunlight?
No, I was in my classroom, didn't have time to go run around.
Okay, yeah. And Lynn pointed out, let's see here, what would be a better light source for our students? Okay. Lynn, I should let you answer that because you're the light expert. So we'll see if he provides an answer to that, but you can buy, flashlights that have more ultraviolet bulbs in them, UVA and B, but just use natural light. It's always more fun. Okay, let's look at the infrared circuit for a minute.
At one of the seminars that I went to that Ken had up here in Seattle, the fellow running it was Matt's,
yeah.
Matt, yeah. And what he did was he pulled we had done built the light side, or it wasn't a Cyberbot though at the time, it was the activity bot, but built the light thing and then pulled all the windows down, all the curtains down in the room, and opened the door. And all of our robots started going out the door in a big train. So it was really interesting.
It is amazing, yeah.
Yeah.
Oh, the IR circuit is a tricky one to build, as some of you have found out, and the component placement is really important. So you need to pay attention to the polarity of the LEDs and differentiate from the photo transistor, which is a light sensor in this one. And you have to assemble these components. We have these as replacement parts as you ever need them. So here's your schematic and then your pictorial, and it uses up about half of the front of the breadboard. So you still have room for other things. And the way this one works is these receivers, which are really just the same thing that's in your TV or your
Ken, you're
DVD.
not presenting for me.
Oh, I'm sorry. Yep, thanks for bringing me back. Great, how's that? Okay, good. All right, so the infrared circuit, here's your schematic and your pictorial, and this one is a little bit difficult to build because the polarity of the IR LEDs, there's a long lead and then there's a short lead, and you must also put the little case across them so the light doesn't scatter to the right and left, which the receiver would get a false detect. So it can see a pretty wide range around it. So when you build this one, you want to make sure that the infrared LED and the receiver are generally pointed in the right direction. And this circuit gives you detection to about 2 feet. And who can tell me where it would fail? In which circumstance would it not work well? Somebody knows. Matt, they're very quiet today. Must be 4 or 5 p.m. somewhere. Small or low? Yeah, small or low might be a problem. So black baseboards are an issue because they absorb the IR light in the same way that if you're using an ultrasonic sensor, a plush animal, a stuffed animal, or your dog might not even be detected. So it's a useful circuit as long as there is a reflective surface that the light can come back on. So the receivers are tuned at the same frequency of light you're sending out. And when you generate that light, it's a 38 kilohertz pulse. And you check the receiver right away after you send that light out. And if the pin state changes, I forget if it goes low or high, but it changes, that shows that there's an object. If there's no object, the light just continues on, or if the object's too far away to be seen and the receiver doesn't change. So
and on that particular one, that's the one I played around with, and I actually got it to incorporate the bumpers as well too for the whiskers. And when it came to a dark object, it actually ended up using the whiskers to back itself out.
all right. Yeah, very good.
Now, is that a good thing? Because I took my whiskers off because I was worried about the whiskers touching the infrared LEDs on the front.
Yeah, it gets tricky. One thing you could do is move the IR circuit to the middle of the breadboard area.
Yeah, and that's what I ended up doing. I actually ended up putting the sensor further back on the board, so that way, even though this touched the little case, the black case didn't touch the wire. Is the way I ended up doing it.
And also this was built in a subsystem. So hopefully you build it and you test it before you add in the roaming. And there is a script as well to find out if there's interference in your room from your 38 kilohertz or whatever you're flashing fluorescence. So one of the use of this, it's really cool that I'll show you right now. Back to the bot farm here. The same receiver, which you see right there, it's just bent over sideways a little bit, can be used to read a Sony TV remote. And the module, the hard work is done for you. So you just have to check for the number of the key that was pressed, basically. And this is set up so that 1 would be left forward, 2 would be straight ahead forward, 3 right forward, 5 stop, 4 would be a sharp turn left, turning in place, and 6, of course, would be the opposite. So you have 9 different kinds of movements you could do here. We'll just give a look at this. And also the microbit will be used to show the number that was pressed. So here's number 1. Oh, actually not showing the number, but showing the direction. So we'll do it like this. Maybe this is helpful. 2, 3, 4, 5. Happy face. Stop. 6, 7, which would be backwards to the left, and then 8 backwards, and 9 is backwards the other way. So let's give it a quick test. Students really like this one too. Here's number 3. So if you notice, 1 wheel is locked and then 1 is turning, which is very different than number 6, turning in place. And number 4 would be the opposite of that. Of course, you can go backwards and turn. A lot of fun with that circuit. And you just need the remote. We sell them, but any universal programmable remote programmed to Sony TV codes would do it. All right, so any questions on the IR or the light following? Okay. Yeah, I think you guys like that one. I like that one a whole bunch. That's one of my favorites. Oh, one more thing, since we're on the infrared stuff, the question came up about using infrared or how to stay on a table was the question. So I'll bring up my document camera again. I'll show you the opposite of avoiding something with infrared, which would be following it if the camera comes to life. Ah, good. All right. So this circuit is actually the IR circuit. We'll show that first because we didn't actually show it. So this is infrared for avoiding objects. You can see it's working up to about a foot or so. Now the opposite of that is using the same circuit with different logic to follow an object. Pretty neat, huh?
Yeah, that's great.
Yeah, it's a lot of fun. And the LEDs again are being used for feedback. Here, just give you a better view of that. So basically the column that's lit up is the side that's detected. By the way, this coffee cup, which is really cool, I got this at our Pirate Gift Exchange. It turns out it's a Bluetooth enabled teacup, keeps everything warm for you, and you can set it with an app on your phone. It's the only time in 25 years of Parallax I enjoyed the the find that I got from the Pirate Gift Exchange. Okay, so let's move on. Carol, do you want to show your project?
Okay.
I invited Carol Haslett over today, and I don't think any of you know her, but she's a very productive contributor to all things robotics and has been for many years, and uses all kinds of microcontrollers and makes some of the more interesting things, as you could see from her shop here. She's not a good bragger, so I'll brag about her, but she does everything from drones to RC airplanes to farm tractors to 3D printing to coding, all kinds of stuff. And I asked her a while ago if she could make something cool with the Cyberbot.
Yeah, this is more to get the kids kind of interested in it. Let me get my thing up. What I did is this little Cyberbot, I added the walker kit to. I added these wings, which flap kind of kinetically as the thing walks. And then there's little flashing LEDs and a microphone for making the stridulation noise, though I haven't got those in this program yet, but let me show you. Okay, you can get it walking, and it walks really well. And then while it's searching for a path, the legs will change. It'll either go straight backwards or turn to one side or turn to the other, depending on what you set in your program for its behavior at different points. It's these points are all numbered so that you can give it pretty specific behavior. And what I wanted it to do was to flash its feelers and make the stridulation noise at the same time that it walked. And this is all real easy for your students to do, printing out the wings, and they're just taped on to the back here. So, you know, there's not a lot of work or soldering or screwing or stuff like that. And the one problem I'm having with getting the feelers and the stridulation to work is I haven't figured out a way yet to multitask with the microbit. If I was just using the parallax controller, I could put them all in separate cogs and they work great. But as soon as I learn that little gimmick, I'll put it out with the code. And the code for this is super, super easy. It's the same code that's in the tutorial, roaming with the Cyberbot. And the only thing you have to change when you put the walkers on it is how much power you give to it. It takes a lot more power to get the walkers going correctly than it does a servo.
Did
So
you
it's just
put
a matter
your
of changing.
battery jumper on VN?
Did I do what?
Did you adjust your jumper on the power supply to the motors to VN?
No, it's on 5 volts.
Oh, okay. That would help too. Put it on VN and you'll get 7.5 volts.
Okay, that's not. That will that be okay to the microbit?
That's just for the servos. So the signal is still from the propeller, but the power will be from the batteries directly that way.
Oh, so Vin and
It'll move faster.
is
It'll go like,
going through the propeller, not the microbit.
yeah, that's right. Mhm.
Oh, that makes a big difference. Okay, put it on Vin then.
And those wings, they flap when it moves. Is that the idea? Because you don't actuate them, right?
No, they're just, let me turn this off and I'll show you. If I can get it up there. They're just mounted on a little triangular type block. You can make that out of anything. I 3D printed it, but you can make it out of anything. It's double back tape to the empty space between the microbit edge board and the back of the breadboard. There's a kind of empty space there. So it's double back tape to that space. And then this is just a piece of tape folded like that. Let me get it. There we go. Can you see it?
Yep.
Okay. And then I put another piece here to kind of keep the wings spread. So I used black tape here for making it look a little more consistent with the wings. It'll all be in the tutorial. I'm going to write a tutorial for it. I've got it partly written already with photos and everything. But
Well,
yeah, when the,
this is
I guess
totally
you can't
cool.
tell on the here, they'll flap as it walks.
Good job.
So that's it. And then you asked something about the GatorBot.
Oh, you got that too.
Yeah, right now it's on a Cyberbot, but I'm gonna switch it over to microbit. All you have to do for the GatorBot is install the gripper sideways instead of, and it works great. So I don't even have to turn it on to get it to work. I just turn this thing back here. See, the jaws will open and then they'll close when you turn it back the other way. And I'm going to make teeth for it and a little head. And then a kind of spiky gator thing going back here and a tail. And it'll all be done with paper. So it'll be easy for students to turn it into a gator.
Wow, very creative.
Yeah, you could put a walker kit on this too, but I'm not going to right now. So that, and then there's a kitty bot coming up. And like I said, all to make it more interesting for the younger kids and teenagers.
Thanks a lot, Carol.
Yep.
And hey, how could people follow up on what you do? What's the easiest way? Your YouTube channel?
Actually, probably Facebook. And you can find that just by Googling Carol Hazel at Facebook.
Yeah, there's only one of her. If you Google Carol Robotics, she'll come up and she'll be your friend. And then we also use the BBC Microbit Facebook group for a lot of discussion.
Yeah, I'm on that too, but I've not really ever posted to it yet.
Thanks for sharing. Any questions for Carol?
I have one, and someone else could maybe answer it too. I'm looking at these and I'm seeing I'm trying to think of something that we could use for our sixth graders, since I heard that the EV3 is going to be discontinued or has been discontinued, and we were thinking of incorporating that program. But even though the box says that these are for 14 and over, I'm seeing projects that our sixth graders could probably handle if they were guided through them.
You could use the block coding and do all kinds of simple robotic stuff with the microbit and motors and LEDs, where they build their own robot or their own chassis from milk cartons and, you know, arts and crafts supplies, just to make something move and have sound and light.
Okay.
I see that done a lot in the sixth grade level. And one person to follow on Twitter for that is Katie Henry. And she's the Microbit US ambassador, and she has a lot of workshops like that.
Okay.
Ken has a candy sorter made out of cardboard. kids might like that. It could be, the program could be adapted over to the microbot.
Mhm.
Okay, last thing I want to share with y'all, and this will take just a minute, then we're gonna go straight to awards, would be the tutorial series.
Missed everything.
Okay, I'm sharing again now, right? Okay, so the cybersecurity tutorial series. Where I've taken you so far, where you've gone, is pretty much through these main lessons. And you'll notice when you get down here, there's a whole bunch of cybersecurity material. And this is more advanced. This is really good for the high school level, but it takes advantage of the microbits radio. And it teaches you some very basics of encryption, okay, and what are called key shifts. And this is very at the core, kind of what we call embedded or physical computing communication that goes along with the Internet of Things. So we read that 60 to 80% of new microcontroller applications are going to be using some internet connectivity in the future. So this is important to know about. And this teaches students how these things work, how they're designed at what we call a very low level. So if you have an extra microbit, you can go through these tutorials. And this has the chat that I had mentioned. So it starts out wide open, and then through the subsequent pages, you add a level of encryption on the transmitter, and then the students get a shifted version of the characters. So if you're familiar, if you've ever heard of ASCII, this uses the ASCII chart, and it will add a value. You can add a value to the letter, and then they'll see another letter. So when I send an A to you and you see it as a D, you can take off 3 and then it becomes an A. So you can add the encryption to the other side. So there's a lot of very good tutorials here. They have moderate use mostly among high school, but one of the things that's wonderful about them is when you bring the robot back in, like in this one, this is just using 2 microbits, 1 microbit to drive the robot, and the other one's a tilt controller. So to my knowledge, this is the most complete Python code. And I just clicked on one tutorial. You see here there are 12 pages that go with it, or 8 pages. So there's all kinds of good content in here that we don't have enough time to go through. I just want you to be aware of it. I can show you an example of it being used with a gripper. I can find my gripper and I'll switch over to the IPvo camera, which has gone missing again. Okay, so I've got one. All right, there we are. So I have a gripper on a robot, and it has, this is the forward, aft, right, left. And then I'm using the buttons on the microbit to open and close the gripper.
Ken, I don't think you're sharing your
sorry.
camera feed.
Okay, I must have had it on the wrong sharing level. Thanks. I'll restart that. Share the whole screen now. How about now, Matt? Is that a thumbs up?
Yep,
Okay,
perfect.
great. All right, so reading the accelerometer on the microbit and then transmitting the angle to the robot, along with the additional use of the buttons. And it's kind of tricky to figure out how to control this. I can see right now I need to switch some things around, but one button is gripper close, and the other one is open. A lot of fun. So we try to build the robot right back into that content. All right, let's go to our award ceremony, unless there are objections. Any questions about some of the things you've seen?
Love it all.
Really? Okay. Well, as you can see, I love it because I have like 12 Cyberbots on my desk, and I have 30 more in a box over there. And if I had the time to set it all up, I would be showing you this application, which I showed on Monday, where you can control them all at once. And this is a real example of how well the radio works on the microbit. And normally with RF devices, and Carol could tell this to be true as well, you don't get to send one value and have every single device receive it the right way. So what the microbit radio does is it actually handles all the error checking and checksums, so that when you say send a number 5, the receiver says, I think I got a 5. And then the transmitter says, I sent you a 5, and they go back and forth 3 times, and then they confirm that, and then it actually provides that number to the microbit. So there's a lot of negotiation that goes on in the background. Okay. While I get this ready, Matt, do you just want to speak briefly about the block programming with Cyberbot that we're working on?
I certainly can. Now, I don't know what our estimated time is for being able to release this, so I know I can't say too much with absolution of when we're going to have this available, but I believe, Nicole, it was you who was asking about capabilities of using the Cyberbots with middle schoolers.
Yes, and I checked out the microbit website too, and that was really helpful. But yeah,
So
I'm curious.
we are currently in the works of, and we have a set. Sorry, I'm used to Teams and now going to Zoom, trying to share. All right, are we sharing?
Yeah,
You're good.
we can see it. We can see it.
So we've finally got it to where make code, we can now program the Cyberbot in make code. So instead of just being able to use Python, you should be able to use make code as well. So this will make it to where the Cyberbot is now much more accessible even to middle school students. No longer required Python to be able to program the Cyberbots. I've been working on doing a few tests with it to try to get it to where we should be able to have it programmable through Bluetooth as well. So that means you should be able to program your Cyberbot 100% wirelessly while using make code. As we're going through, we're adding in more programs, more functionality, and making it easier for the students to be able to have access to it. We also have a cyber.org library that we're currently working on. And let's see if I can pull that up as well. Yep. So this would be used for elementary school and middle school. But we have functions that are able to be used for encryption on the on the microbit, being able to finally use dictionaries and make code, and then a few other bells and whistles that we're adding in. So keep an eye on cyber.org's curricula as these are being released over the course of the next few months.
Matt, hasn't that already been out there for a while?
Which
I remember
one?
using what we're looking at here, the make code.
Make code has, but Cyberbot support is totally new.
Make code's been out for years now.
Okay,
the
because I
cyber.org
remember a while back using it on a microbit.
Yes, so make code has been used on the microbit since I believe day one, right, Ken?
Yeah, that was its primary programming interface.
And
Oh,
then
I
that's-
see you added a Cyberbot module.
Yes, ma'am.
You've got it,
Okay.
Carol. That's exactly what's happened. And so Matt has done some custom block coding to make that Cyberbot module accessible through the blocks, and then created other blocks to do all the robot functions. And this is a way
Okay.
for third-party developers like us to plug our work into here. And so they'll go to, it's really cool to access it. And it's not out yet. He just types in the GitHub URL, and then the blocks kind of populate themselves. And I just want to say, this is no small feat. Matt works very quietly, is a very humble person, unlike me, and gets big things done in the background, and then he eventually shares them. And this is going to be wonderful when we're ready.
I'm always afraid I'm going to make a mistake or I'm going to say something and not think it through while talking. So I just realized a while back, just stay quiet and maybe give stuff whenever you know that it's worth giving.
You do great, and we're glad you're here.
Yeah, this is awesome.
Our biggest hope is going to be to get the Cyberbot library published through MakeCode so that you'll be able to, instead of having to type in the GitHub link, students will be able to just go on and immediately be able to find the Cyberbot extension right here.
This is thrilling for middle school because I was, loving all of this, and I was thinking of a few students, so this could be enrichment that are already learning Python on their own and doing all that. But with the blocks, it opens it up to all the students, which could be that interest they need to fall in love with computer science. So, wow, thank you.
Absolutely. Absolutely.
Excuse me, do you mind if I ask a question?
Sure.
I've been using Tinkercad, and Tinkercad has a microbit on it. And you can program Tinkercad this way and sensors as well as Arduino. Does microbit through cyber.org work with Tinkercad at all? I mean, coordinate?
I did not know that Tinkercad had a microbit function on it.
It's a new function.
Oh, it does. It has a fully functional microbit and a fully functional Arduino.
Yeah, fully
Uno.
functional within the confines of the access they give you to the tool. So yeah, that's true, but like you can't bring in your own libraries and your own hardware that I'm aware of. You can use what they make available.
Sure.
So
Also, this.
Well, I mean, this extends it greatly. That's my point.
it does, yeah.
Ken, this is a function that I didn't have a chance to show you the other day, but you were talking earlier about the Cyberbot having the issue, or any of the bots having the issue of the servos not always functioning in the same way, where you're going to get some slight turns one way or another.
Mhm.
Josh and I were working on this one, and it's probably one of my personal favorites, being able
Oh.
to calibrate the individual servos so you can get them to be lined up exactly how you need them to be.
Beautiful.
So this is just a sneak peek on it. We, as I said, I don't want us to be giving out anything until we know that y'all are getting what y'all absolutely deserve to get, which is the very best to be able to work with. But over the course of the next few months, we're going to start releasing not only this library, but also the library that's for cyber.org that involves the encryption modules and a few of the other bells and whistles that we feel like MakeCode is sorely missing.
It's totally awesome. Good work.
And this is something our school uses Chromebooks, so there are a lot of coding programs that we have access to that our students can't actually use because they have Chromebooks. So
Yeah.
MakeCode is something they can do with Chromebooks, right? They can do all this with a Chromebook. That's awesome.
Actually, that from my side of the fence, that is great, because what I end up doing is I use the MakeCode block to get them first programming. And I actually use a smaller little robot. It's called a McQueen robot. That's very, very small, that I use to start them to learn how to program. And then I transition them over to, I'm currently using the Parallax one is the one I use. But with this, I can just go straight through the robot without having to go through this one. So makes it a little bit easier. I really like that.
Yeah.
Not only that, but also we're hoping to have it to where all of the sensors that you would be able to use with the Cyberbot in Python, you're going to be able to use all of those in MakeCode as well with the Cyberbot. So ping sensor, color pal, you name it.
That would make my curriculum a very, very much more streamlined.
Yeah.
Perfect.
We're glad to hear you like that. And that's going to be useful to make your job easier, and it lets you accommodate a wider skill range of students too.
Yes, very much so.
Yeah. That's great news. I have tons of special ed students, and one of my problems, I was trying to come up with a creative way to sell my principal on it, being able to teach them STEM. But then I was thinking, how am I going to actually pull off whatever I sell her on? But this is really doable.
I'm there with you. I have a principal who wants something that's, where they build
Yeah.
projects quickly, but it's something that the students can wrap their minds around right away and
Yeah.
approachable for the teachers who have never done any coding. Like, that's a pretty big package.
Yeah.
Not asking for a lot, are they? No, not at all.
Yeah. Not at all.
So to summarize, with the microbit, you have make code, which is their block system, and make it code it works with that. And then make it code it also works with Python. And then Lynn pointed out Tinkercad added microbit support. So there are a lot of tools here all of a sudden. And what's really strange to me is that I have universities that are using the microbit now because of the Python capability. So it is kind of a winning tool for elementary all the way up.
Yeah.
It's good because you guys don't have to keep buying and throwing away hardware now. So obsoleting you. So some of the craziness that was submitted by all of you over the last couple of days, I just was able to collect it up in a folder here and we'll get a quick look at it. So this was a really good fail from Deborah. And this was totally frustrating. You open a bag and the little rolling parts that you need roll right into the register on the ground. Goodbye. So this is a good recovery from a strong fail, and she used straws to make standoffs. And that works because the screw is still making contact with the chassis, which is ground. So good job to you. Next one is this one came in, and this came in from a prior class, but I want to show it. So it's escaping from corners and then parking in the dark. So this is really bouncing around, looking for a dark spot to call home.
Mm.
And there's this parking lot here. How about that?
Pretty cool.
Yeah. And then next up,
Yeah, don't let trucks do that. Trucks get stuck in the highway overpass.
Yeah.
oh, we got pictures of that too. So this is interesting when you put robots in front of dogs. And this one's from Felicia. I guess she has 3 dogs. They don't seem to do too much with it. Some of them go crazy, but when you make it a little more organic looking, it kind of bothers them a bit. But they know from smells right away, this thing is not another animal.
What I did was I went to my veterinarian's office. I'm good friends with him, and he has dogs that love to play. But today they were afraid of the robot. They wouldn't play with it at all, except for the Belgian Malinois. He was the only one.
Yeah, but Malinois is a cray-cray. They're not afraid of anything.
So when you put it in front of a child, like Stephanie did, this is always interesting to me. So if you give a little kid something that looks like it's for a little kid, they treat it that way. So they'll definitely, grab a stuffed animal and by the arm and run off with it really quick. But I've noticed over and over through the years, when you give them robots, you don't tell them anything about it, you just put it in front of them. They're really respectful of what they're looking at because of all these wires sticking out and it looks kind of technical. And it's so common to see a little kid walk up, touch it gently, back off and watch. They're all like this. And another good picture video that she provided. This really shows it.
Yeah.
Totally. I don't think it showed the audio.
Oh, is it good audio?
No, it had audio, but I don't think it showed.
Let me see if it came in here. I just upped my volume.
My experience at Robothon and robot shows is that if you have a ping on front of one, the kids just endlessly keep putting their hands in front of it because it reacts to them.
That face is like, not what I wanted.
Yeah, but he was making car sounds. That was the song.
You may have to check share sound before you share your screen.
Is that, I don't know how you share sound on Zoom.
Oh, it's
when you click share, there's a button in the bottom left corner that says
yeah, you can still get to it through if you click on your green area at the top of your share.
Yeah.
and right click where it says more, there should be a button that says share sound. I make this mistake every single day.
Wow, this has been tough for me, and I keep failing there. I'll figure it out without all you watching me.
Okay.
And then Karen Dave, she's got this basset hound that looks sort of confused, concerned, who I
Thanks
offended.
for that.
I called him a beagle, which he absolutely is not.
No, she is not. There's another one in the background too, running from it.
Very funny. And
My
Lynn
cat
Fleming,
just totally ignored it.
so Lynn Fleming sent in this absolutely crazy news article. Cyborg bot escapes. Be on the lookout for it. Reports by eyewitnesses state that it morphed from a similar parallax shield bot. This bot is known to be able to communicate with other bots of its known kind. And I said, this one's clever. Every other bot we've produced only has some of the possibilities of the smart bot. It talks and sings. And this robot was seen escaping from something very southern to me, the Grits and Microbit facility with red beans.
Grits. I'm from Georgia.
Yeah.
If you only had cheese grits.
And then just to show you the pandemic is having an influence on everybody, this one came in from Nicole Burke, and this is with her kids and on a trip showing the silly goose, which is invisible. Nothing to do with robotics.
The silly goose.
It's been a long year. And then we did
My
get a
son
cat
had
video.
to invent a pet since we couldn't get a pet. And he's been lovely.
It worked.
Do you have sound now? I guess you do. So here we got a figure-8 robot with a very disinterested, ungracious, bored cat. Was I offending to your cat, Sarah?
But look at the interference patterns on the screen.
Yeah.
That was my cat's reaction to any of my robots.
I love it.
It's like, ah.
I think the cat's main concern is whether or not there will be food competition later in the day. They do a really good job worrying about themselves, don't they?
Yes, they do.
And Stacy Wright.
I'm wondering if you put a laser in front of that, would it give you a different reaction?
No, she learned lasers really quick and decided, yeah, nothing there.
And this would be a new version of an equity problem. The old robot getting displaced by the new upgrade that showed up.
Yeah, I don't have any pets, so I thought about my robots and I said, wow, I've come far from the color-coded connectors to the real thing.
Yeah, to electronics. It's a lot of progress. And let's see, other craziness. Speaking of low bridges, so Gene Pearson sent in a series of pictures. He lives in Chicago by two bridges that are 75 yards apart. And apparently one has a sign that says 12-2 and the other one says 13-2. So trucks smash into the 13-6. So they go under the tall bridge thinking everything is fine until they're a few feet down the road and bam. And I guess this happens all the time where he lives. Yeah, craziness. And so he wrote a letter to the city commissioners or whoever the authorities would be saying, make the signs the same and make them all the lower level, and the drivers will have fewer accidents, which apparently has happened. And really his idea here was use a sensor on top of the truck. And he suggested the ping. And what would probably work even better would be a laser, because they could look out to 100 meters or so. But it is amazing we still have these kinds of problems. humans. And what else did I get? Picture of Gene's pandemic radio. So he's an amateur radio operator and seems to have worked all through the pandemic. And here's his workbench. Has some ideas for integrating microcontrollers with radio communication, I guess. So very cool. Did I miss anybody's contribution? Okay, if you did send something in and it wasn't shown, let me know afterwards. So the winners, yeah.
I sent a failure, but maybe it didn't get to you yet. It said it was going to take a while. And I sent it yesterday, but if it didn't get there, I'm sorry.
All right, I'll find that and I'll share it out if it arrives. So the last two things, oh yeah, the prizes. Okay, what do you get? You're all winners. I didn't have time to decide who the losers are. So I think what I'm going to be sending out would be these line follower kits.
Awesome.
Yes. More free stuff.
Line follower kit.
Yeah, so much like those scholarships. Now, you teachers, you tell your students, go claim the scholarship. Nobody's going to get it. Now, I told you as well that no one's going to grab the prizes. So everyone that played won. Same applies to you guys. So congrats to you all who won something. Last thing here. I mentioned in the summer, we're releasing the What's a Microcontroller with Python. So right now, if you went to learn.parallax.com and you scroll down to language, and under Python, you only see the Cyberbot. This is because we're having trouble with our website and we've not figured out how to make this other series appear. But there's something growing quietly in the background called What's a Microcontroller with Python and Microbit. It's a pre-engineering series really for high school. And one of the coolest things about it is there is a virtual oscilloscope that runs in your Chrome browser. And this is all about Ohm's law, Kirchhoff's law, measuring voltage, resistance, and doing real electronic wiring. So it comes out this summer. And it's using the microbit, and Parallax has a parts kit for it that some people are already getting, and it's available in a bunch of different formats. Basically, there's the parts alone that are this bag of parts for $40, and then there is the version with the edge adapter and no microbit. Then there's a version with everything. So this was funded by cyber.org, and we've had Andy on it for a year. Or actually will be a year soon, and June, July is our release date. And then through August, we'll have Andy do some sessions on this series with whoever wants to join. And we'll send out the hardware again just to make it easy to get you in there. And if you're interested in Cyberbots in the future for your school, I can help you with that. So the sales portion of this presentation lasts for 1 minute, but there are a bunch of ways to get it. You can buy the robots alone or 12 packs. So if you buy robots alone, they're $239, but there's a quantity discount where they go down to $215. Unfortunately, I wish things were cheaper, but this last year we were faced with a lot of cost increases on components and tariffs. So our costs went up. Yep. I think others have experienced this too.
Now, do you guys have a kit where you can do the adaptation to where like you can get the older robots and upgrade them to these?
Yeah, we do. So if you have a Bobot or a ShieldBot, there's a upgrade or a retrofit kit you can buy. Yeah, so everything is pretty much portable below the electronics, usually is how I consider it. And this way the accessories can work across any platforms. This is a good kit. It just says out of stock because we sold them all, but if you have lots of money, this is the best thing to get. It includes 12 of everything. And this is like the giant box of fireworks that you would get, or you always wanted as a kid. So it's many 3 feet by 3 feet by 3 feet.
Okay. How many kids would you put with each bot?
Well, I used to see one robot per student. With the Cyberbot, 2 students per robot is good because one can do the circuit building and one can do the Python scripting, then switch. And I think
Okay.
that's pretty much a standard model. In some areas I see lower ratios, 1 kit per 3 students, but generally we see a lot of small classes using this.
Okay. I couldn't figure out what I would do, what I would have the third student do besides keep time, which would be totally boring and a waste.
Yeah. Yeah. So the hardware in here, the extras are the line follower, the ping sensor with the servo, and the there's a classroom banner, rechargeable batteries, and the remote controls. And when you go this way, you can do not only all the tutorials, but you can do all the projects, which would be, I didn't go there the right way. I'll take you there one other way. As you scroll through the tutorials on the bottom, you come across projects, and the 12-pack plus includes all the hardware for these projects.
So this would be like advanced 8th graders.
Yeah, I think so. Yeah. So with that, 35 students, large classroom, it can be tough to run. I just want to impress on you then with your students. I have classes where they pretty much freely hand out the hardware and let the kids go, and I think that's a great approach. But you know what it takes to build a robot now. You know about the gotchas, you know, some of which are maybe product design or just the nature of working with electronics, but absolutely force them to take their time, introduce little things and little steps, and master the pieces as you go. Don't let their enthusiasm railroad you into just letting it go in the class and missing all those steps that they should get through the tutorials, okay? That's my encouragement, because it can be really hard to backfill those pieces.
Okay, 12 packs for 37. My classes are between 15 to 22 students, so this would be awesome.
And also remember, you can apply for free hardware through cyber.org, the grant that comes out, and that's quarterly. And that closes then, it would be in June, I think, Matt?
Okay, 15.
I'm not 100% sure. That's going to be
It's a
just
Cali
Kevin or
question.
Cali question.
Yeah.
Okay, so I basically need 1 12-pack per class.
Oh, if you have an odd number, Carl, we can build a Carl version 12-pack that's 18-pack or whatever it is with the right quantity.
So the 12 packs are going to come back? They'll be
Yeah,
in.
yeah. They'll be in stock by the end of today, usually.
Okay, so.
But with school purchase orders, we approve all of them and usually fill them in a few days. So don't worry about something being out of stock as a reason not to get it.
Okay.
Now I want to ask those who are hanging out still, do you feel like you have enough information to proceed on your own?
Once I actually go through and build a bot, but I just found out today I'll be with 3rd graders for the state test, and I don't have to do any lesson plan, so I'll be building my bot next week. I'll send you all the pictures.
Your bot's been in quarantine.
Yeah, but I got it. Yeah, I got it.
A couple of the older parallax bots. So if you can tell me more about the retrofit kit, that would be great.
Sure, let's go look at it.
Okay.
When you say older, are they bobots or are they shield bots?
Oh, I'll have to go in the other room and look. I can do that and be back in 2 minutes.
Yeah, okay.
Okay.
Yeah, and it's very common for teachers to inherit a class of older parallax hardware. And when that happens, like I've been working with Felicia, I'll trade out things and just try to do what I could do without upsetting the rest of our staff behind the scenes to get you, a complete set of the desired hardware. Other questions while she produces her old hardware?
The one question I do have is you were mentioning back on Monday about getting a login for the teachers' resources.
Yep.
Yeah, I never ended up receiving that particular email.
Okay, could you reply to one of my emails and say, I need the login?
Okay, I
Yep.
will do that.
So the Cyberbot Conversion Kit, this could take you from a Bobot or ShieldBot to a Cyberbot.
Okay. Oh. So there are 3 fifth-grade classes. 3 sixth-grade classes. There are 4 seventh-grade classes, so there will be 4 eighth-grade classes. So there's 3, 3, and 10 classes overall.
Any other questions I could help you out with? So I think y'all know that we have this Educator Hotline. I'll just show you that. Seems to be missing here from. Actually, if you just go to the Parallax homepage, it's on the top of the page, and I'll just tell you what it is. So I'm logged in, so our website looks a little bit funny, but on the top of our website, you'll see the Educator Hotline number. And I personally answer that because I really like the education part of the business and want to help the teachers out. So you can call that anytime. It rings early in the morning for me usually, which is fine. But whatever you want to know, if you're in class and things aren't working right, this is our no nonsense way to get you some answers quick. So it's very common. We talk to students, teacher might hand us the phone to the student, or you might have some issue that may have popped up because software has changed or whatever.
Okay.
Don't want you to be stuck. Just call us. Okay. Don't even write an email. You can get to a human.
Wow.
I get a little
Yeah.
frustrated with that after calling a cell phone company or something. Yeah.
Dan, how come you have stuff in your cart? Do you have to buy it through the store?
The amount of hardware, Carol, I have checked out through the years, probably $100,000 of hardware.
So I have the activity bot.
Oh, the activity bot's difficult to convert.
And the activity bot 360.
So let me ask you a question about them. Are they opened?
Yes. Yes, I think they're all opened.
How many do you have? And are they built?
So yeah, it looks like all of them are built.
Those are a little more difficult for me to convert because they have a special motor. But you know what you could do is take the activity bot class next week.
Okay.
Also, if you have any kids that are just really excelling what you have, stripping out whatever you have at school and you can't keep them moving, we have a program for them too. It's called the Future Innovators Fund.
Okay.
And you can come in here and fill out this application for your student and say what hardware you'd like us to send them.
Okay.
And we approve it. Pretty much 100%. We just want to know that someone took the time to fill out the application. So at the moment, there's $4,621 there, and we've had only 3 requests.
I was just gonna, because I do have a couple of students who, like, they finish all my work. I teach math and social science and STEM, and they're like, okay, Mrs. Burke, and they see me playing with different things like the 3D printer or the robots, and I'm tempted to like give them, like, yeah, I have it all here. You guys could take this and play with something.
Yeah, if there are students that have are just moving on so quick, or you think this would be a big aid to their learning, you know, there's no real criteria other than you think the student would be productive with it.
Yeah.
We do try to favor those who need it, who don't have the financial support, but we have no way of checking that.
Yeah.
Nicole?
Yes.
I have an activity bot set up in the butterfly configuration, and it works completely because I use the different cogs in the board to have everything run at the same time. So I'll show that at the next activity bot thing, if it's okay with Ken.
Yeah, I love that.
Yeah.
So she's talking about the class next week, and get you a link to that in case you want to sign up. You could jump in and out, but the activity bot is a very capable robot, and it could do everything in parallel.
I also teach Girls Who Code, the Girls Who Code Club, which is open to all students at our school. And I have students who show up at my class after school and they want me to give them something to do. So something like this might be more appropriate for that. But yeah, that's all great. Well, I can maybe take the activity bot class next week. Hopefully I can.
Yeah, you could always jump in and out. I'm trying to find the link for it. Actually, I'll just go to my Zoom and get it. But it's going to be the same old presenter. And then after that, the following week is the Shield bot class with Andy.
Andy Lindsay?
Yeah.
Oh, I'll watch that.
Yeah, you might want to do that. Andy gets into more engineering, and he's a very skilled instructor too. So here's the
Yeah,
link next week.
I've read his stuff, but I've never met him.
Andy Lindsay is probably published almost as much as Forrest Mims at this point.
I think I have everything Forrest Mims published.
Well, okay then. It seems we could start our weekend. Want to thank all of you for sticking with us through the week, and congrats on your new skills too.
Yeah. Well, I want to say thanks because you also, not only for this, which is great, and the new Gator bots and all we just saw, but you also gave, through the Future Innovators Fund, a robot to one of my students, Orsima Cassahum is her name. I have a picture of when she was in 5th grade. I don't have a picture of her now, and she's in 8th grade.
Awesome. How did it work out for her? Do you know?
She loves it. She has one goal in mind: learn everything that she can. This is her. Can you see my screen?
Yeah, looks great.
Yeah, this is her, the girl here. That's her brother, Timbit. And these are 2 other students of mine, Sunny and Johnny Gugaloo. And this was my mentor at Temple, Dr. Jamie Bracy. Well, Green now, she's married again, Dr. Jamie Bracy Green. But she's no longer at Temple, and so we don't have Mesa in Pennsylvania anymore. But this was a smart robot car competition.
And Carl, is this the girl who we figured was falling out of, because of COVID, was kind of vaporizing behind the scenes and may not return to the coding class? Was that part of her story?
Yeah.
Okay, I remember reading it. Yeah.
Yeah, but she'll be fine. Next year she's going to go to Central High School, which has a great engineering program. So she'll get some more things.
I have a student in mind who his parents have struggled. They struggled before the COVID season, but every time he's in STEM class, he really picks things up quickly. But yeah, he would be one of those students who.
That's the one we're looking for. And when we can get the hardware in their hands, we're probably making a good career option for them in the future, is my view of it.
Yeah, because all 4 of those students are they've been here for a while. The kids, they're citizens, but their parents, Arsima and Timbit's mom and dad, are Ethiopian. Sunny and Johnny's mom and dad are from a small village in India. And they had 2 ideas. You're either going to be a doctor or a lawyer. And I'm saying, wait, there are other things. And they're saying, no offense, teachers don't make any money. And I'm saying, okay, but there are other things. Like we could try engineering, and their other thing was dentist. And they're saying, well, dentist is kind of a doctor. So they really didn't have a clue about engineering.
You know, most of the engineers I know and technical people worked with their hands and their mind when they were young. Like I bet Matt probably as a kid built a lot of things.
Legos all day long to the point where I am 3D printing my own Legos. And taking apart the toaster.
You sound like my brother.
I've been 3D printing some Lego stuff too.
Well, in our house, we wanted two things that we never got, but what we got was way better. What we really wanted was an Atari 2600 and a motorbike. But what my dad gave us instead were Dremel tools, soldering irons, trips to Radio Shack, the hobby store, and you know, building things around the house, which was wow, way better. And when we had a problem in our house, I remember as a kid when our plumbing blew up once, it froze. And I said to him, Dad, call the plumber. And he said, you're looking at him. You're a plumber too. You just don't know it yet.
My dad spent the last 12 years of his working career teaching electronics at Great Lakes Naval Training Center. And I used to draw this was back in the days of overhead projectors. So I used to draw his schematics for that. And that's how I ended up getting into electronics.
It's child influences.
Good dads, that's what counts.
Yeah. Parents that give you access to things and teachers that show you, at least give you some experience and some access to something you would not have seen.
Yeah, makes all the difference in the world.
Yeah, so much of your job, it seems is really just about exposing them to something rather than telling them about it, isn't it?
Yeah.
But anyway, I still do my own plumbing, but yesterday was an exception. Got this crazy idea to remodel the shower during the pandemic, like a lot of other people have, and just been so much work. And I was not about to redo all the plumbing on my own. I gave up.
Bill says you can borrow his tractor anytime you want.
Yeah, just drive it down I-5 for about 6 days.
Yeah. He got the backhoe attachment too.
It's a big toy.
You gotta
Oh
have
God, yeah.
You gotta have a backhoe on a tractor. Gosh.